Well, good day, students, and welcome to the last lesson of the year. Is lesson 9.6, factoring special polynomials. I would just remind you here that this format, x squared plus 2xy plus y squared, is called a perfect square trinomial, and the last term will be positive. All right, so what happens is you get x plus y times x plus y, which equals x plus y squared. That's thus a perfect square trinomial because these terms multiplied together give you this term. And then on the negative side, you get x minus y times x minus y, which is x minus y squared. Will give you this perfect square trinomial format of x squared minus 2xy plus y squared. So we're going to look at them. Remember, the first and the last terms must be perfect squares. So let's go to, we're on page 455, and the directions to begin with are to state whether each expression is a perfect square trinomial. So, not the first and the last term must be perfect squares. So is x squared perfect square? Yes. Is 64 a perfect square? Yes. All right, so then we have here, do we have this format? Do we have one of these formats? Do we have an x plus y times x plus y, which will give you a positive sign in the middle, or an x minus y times an x minus y? And so we have here an x, in this case, we have, x plus 8 times x plus 8, and that gives you, and so the answer is that is yes. All right, so let's do the next one. We have 4b squared minus 32bc plus 64c squared. Are the first and the last terms perfect squares? And the answer is yes, they are. Since the middle term is negative, then you're going to have a negative square. So it would be 2b minus 8c times 2b minus 8c. So that is a yes again. This is a perfect square. All right, so remember the negative times negative is a positive. So look at this one, number 6. Is this a perfect square trinomial? Notice neither the first or the last terms are perfect squares, so this cannot be. So that is a no. All right, so now they want you to factor. So you're just going to ask yourself, first of all, you see the middle term is positive, so it's got to be a positive positive perfect square. So the square root of x squared is x. The square root of 25 is 5, so it's x plus 5 squared. Let's do the next one. So again, are these perfect squares, the front and the last? Yes. So this is the square root of 36a squared is 6a. Now you got the negative sign in the middle, which means you have a negative sign here in the middle, minus 5. And it will be squared. And then, of course, then 5 times 6 is 30, so you get two negative 30s, and you get a negative 60 for the middle term. How about this one? The positive, we have a positive in the middle, so square root of 16 is 4. Square root of x squared is x. Got the positive in the middle, so plus y squared. Now, obviously, 4 times 1y is, 4xy, plus 4xy is 8xy in the middle term. All right, let's go to the difference of two squares. X plus y times x minus y is called the difference of two squares and has no middle term. So then we have two tests to determine whether a binomial is the difference of two squares. The first test is there a negative sign in the middle? And the second test is, are both terms perfect squares? So let's look at this first one. The directions say, state whether the expression is the difference of two squares and explain. So, do we have a negative sign in the middle? Yes, we do. Is 9 a perfect square? So yes, it's 3 cubed, right? And plus 4r, that's your times 3q minus 4r. And obviously then that middle, the difference of two squares will eliminate your middle term. Let's try it. So that is a yes. All right, so what about this one? Do we have perfect squares at the front and the back? Yes, we do. Do we have a negative sign in the middle? Yes, we do. So let's just take the square root. So it's 2k squared plus 5l, all right, times 2k squared minus 5l. And that creates the loss of the middle term. And that is a yes. What about 12? Is the first term a perfect square? Yes. Is the last term? No. 5 is not a perfect square. So the answer to this one is no, that is not a perfect, the difference of two squares. That's not the difference. So 13 says factor a squared minus b squared. Well, we have two terms, so it has, if it's going to be factorable, it has to be the difference of two squares. So it's going to be a plus b times what? Well, to get the no term out of the middle, it's got to be a minus b. And that gives you then a squared minus b squared. All right, let's do 14. Here we go. We get the negative sign in the middle. Square root of 36 is 6x squared plus square root of 49 is 7y. Now this is 6x, but this should be an x. Plus 7y, and then 6x minus 7y. That eliminates your middle term. The difference of two squares. And our last one, 4m squared minus 144n squared. So square root of 4 is 2m plus square root of 144 is 12n times 2m minus 12n. That's the end of your example. So don't forget to turn your work in digitally. Each lesson's worth 30 points. And you need to do them to get your credits. So, hope you've enjoyed this. It's been different for me. Hey, look at here. I bet you thought you were going to see a cat. Well, no, I didn't. Well, I got a text question from one of the students. Really? Yeah, it was Emma. Emma wanted to know if there was going to be a final exam. Well, now that you mention it, maybe we should have a final exam. Yeah, that was Emma's idea. But maybe you should let me write the final exam. Well, if I did, what kind of final exam would you write? Oh, I see. Can you name all of the critters that were in these lessons in order from first to last? Of course, the last one being me, your favorite one. And don't forget, you can always call your teacher. Do you think that was really necessary? Of course it was. Thanks, Emma.